If we look at the first molecule, we have a negative charge, and so we want to move electrons away from that negative charge in order to stabilize it. So our first step would be to move the electrons here to the left. If we move them to the right, we'd be adding them to a carbon which already has 4 bonds and there's no pi bond to break, so we can't move them down. We have to be moving them up to the left. Now this carbon here already has 4 bonds, so when we move these electrons over, we're adding a 5th bond, so at the same time we're going to have to break a bond. Once we've formed the new pi bond and broken a pi bond, we're no longer breaking any octets, so we can draw that as an intermediate resonance structure, which would look like this, with a negative charge up on the oxygen and a double bond between the carbon here and the carbon here. Now, can we stabilize this charge anymore? There's not really anywhere else to put that negative charge. There's no way that we can move electrons away from that negative charge. So that is it for us. That is the only major resonance structure that will stabilize that negative charge. For the next example down, again, we have a negative charge, and so we want to move electrons away to stabilize it. So I'm going to move them towards where this pi bond is, so that again we can break this pi bond at the same time, so that we're not breaking octet on this carbon here. So that's going to give us a structure that looks like this. So now these electrons are a lone pair on this carbon here, and we've formed a new pi bond there. And here's the rest of the molecule. So we have the same net charge of -1. Now, unlike the structure above, we can keep going with this one. So we can push this lone pair in here, and then to not break octet on this carbon, at the same time we're going to have to break this pi bond, and that's okay for oxygen. It won't break its octet. If you have trouble seeing when octet will be broken or not, draw in all of your hydrogens and all of your lone pairs so that you can always be safe and count them. All right, and there is our third major resonance structure that stabilizes that negative charge. Now for the third one down here, we can start by moving these electrons away from the negative charge. We can move them either to the left or to the right. I'm going to start by moving them to the left. So I'm going to take them and move them down here. This carbon here has a hydrogen off of it, so it already has 4 bonds, so I'm going to need to break this pi bond in order to not break its octet. So here is the intermediate species, which now has a lone pair on this carbon. We can keep pushing this lone pair away from the negative charge. We're going to have to break this pi bond so we don't break the octet of this carbon here. And that's going to give us another resonance structure that now puts the negative charge on the oxygen. We'd expect this one to be a big resonance contributor since it's putting the negative charge on the most electronegative atom. Now here we're finished pushing to the left. So if I go back though, you'll notice that there's something else I could have chosen to do at the beginning. It's possible that I could have instead chosen to take this lone pair and put it to the right and then break this pi bond here. That would have given us an alternate resonance structure, as so, which puts the negative charge on the end. So all 4 of these are valid resonance structures for this species.